All right, everybody. My name's Dean Davison. I'm doing this for Kill the Flashover. Basically, what we're doing here is we're going to show how fire operates. First things first, you have oxygen. You have the fuel, which you can also see the heat from the flare here. So what we're going to do is actually have that come inside. I'm leaving this open to get some oxygen to start the fire up, because every fire needs oxygen, every fire needs fuel, and every fire needs some heat. So we got that going on right now. As you see, we have some off-gassing or paralysis going on here in the rear of this, through some of these little cracks that are in the rear of this. What I'm going to do is I'm going to open it up, and you can see there's flames already starting in there. So the oxygen's allowing flames to start. So what we're going to do is, this is a compartment fire, so we got one compartment on fire. To get the compartment to move, air to move, you would pull another compartment. So I'm going to pull this compartment out, and as you see, with the neutral plane here is kind of about right here. Over here, you're not getting much smoke yet. That's because we have nowhere for it to travel. But we start closing this up, it's going to have to find its exit somewhere. So I'm going to leave a little bit of air going in there. So what will happen is you'll start getting smoke starting to show over here. As you see, we get some smoke showing from the eaves here. That's going up through this second compartment. So as I open up different compartments, you'll see a few things. This compartment has some smoke, but it's going up because of the fact that the fire room's below it. So we're getting lighter smoke here, and that's basically a light smoke, so it means it's not burning too rich yet. When it gets richer, you're going to get black smoke. So as you see to the right here, there's a little crack in the side here, not a crack, but a seam where there's no caulk. It was actually some off-gassing going on there. So smoke's starting to get heavier here because of the closure down here. This is keeping this from spreading. So if I cut all these off, you'll start seeing less smoke because I have no oxygen. The oxygen is everything. That little hole on top is letting off some, and like I said, the cracks in the back, but the majority, you don't see oxygen. You don't see smoke coming out of the front door. So the fire is not going to spread. It's going to eventually put itself out due to the fact it has no oxygen. So we open this back up, and the fire's out. There's no fire, no active fire, but now I've let air in. So we have a little flame starting back up in the back here. I'm actually going to add some fuel so we can get this going a little bit further. Top this roof thing. So what you're going to see here is ventilation starting. Someone cuts a hole in the roof, you're going to actually get heavier smoke travel, because this is an open area, traveling through the rooms up to the roof. So it's actually ventilating and clearing up parts of these areas and compartments. The compartmentalization is important. Because if you close the door in a fire, you actually kill the fire. You have to have all three components. So what I've done there is added more oxygen. What should happen now, because of the fuel in the other location, this is the access route for it to go. I'm going to shut this over. Now the majority of the smoke should come out of this area, because there's no air there, there's no air in this room, and there's no air in this room. So it's going to follow the travel pattern That travel pattern is through this room, which has a hole. They left the door open. This is why we tell you not to have your door left open at night, because at night, if you leave your door open, fire can spread into that built area. So then it will go to here. As you see, we have a thermal plane starting from the off smoking, and what will happen is the fire will get up here and it'll become more turbulent. As you see, it is becoming more turbulent. The white gas is from not having a bunch of fuel. That's just your Class A materials that we're using. But as you see, it'll get darker. When it gets darker, it means the fire is burning hotter and richer. So here, as you see, we have a lot going on from this as the thermal plane comes down. And this will eventually will be where that fire is going to wind up coming out of. Of course, we got a lot of wind today. We'll take a look down here and see what's going on. That's still got good burning going on. There she is. Now we got oxygen that's coming out. So we got flame showing because I've just opened the front door. Because that's an exhausting mechanism. You can see some smoke coming out through this crack back here, but I'm going to show that. That's kind of like showing that it's getting the pressure coming from the back here. So that's how these fires spread so rapidly. So if we close this off, and open that up, I just vented the roof, and now you can see front door is open, which firefighters should never do. We should close the door behind us. Now that fire's going to push smoke up through the roof, and through that roof, you're going to be ventilating the smoke out, which will improve, if you close your door, will improve the visibility if you're going in to fight a fire. But the main thing you got to remember here is that we need to ventilate. As you see, it's getting really good now, ventilation. It's starting to get darker a little bit in the smoke pattern. And basically where we're going is the fire spreading, and because the air is available on the roof for ventilation, it's letting the smoke come up. So the visibility for a firefighter would actually be better. So I'll let this kick for a little bit. I see I got the front here I have a little hole for like what would be your end here. At the other side, we have it closed up. So there's not as much smoke coming up, but you see it's becoming more turbulent. And if there's no water put on the fire, and everybody gets out of the house, it'll eventually flash over. And the ventilation through the roof is important because if you're going to fight a fire, you don't want to be on the inside of that when it flashes. So we don't want to flash over. That's the amazing importance of having a ventilation stream. But as you see, it's becoming more turbulent, getting darker, and where the fire has definitely spread. If I open up now, you got fire coming out the front door. So that room flashed. So like you see, you have flames coming out the front door, doors flashed, and it's also got to the second story, because you can see flames there. So we're going to move this back in. There's an idea of just cracking a window, and then we ventilate here. Boom. It's now to the second floor. I'll put a little water on this. Now you have that second story fully live because we've closed that ventilation hole. So now the ventilation hole has nowhere to go. Put a little water on this so it don't get out of control. Probably are going to get it. As you see, when you put water on this, it lightens up. So you're taking the fuels away because you need heat, water. I mean, you need heat, air, and fuel. So when you add water to it, so that's pretty much how we doing this burn house. Hope you enjoyed the presentation. Have a good one.